Hi, this is Jason Baker. I'm back again for to cover some quick topics, some more advanced topics related to shell scripting. These are topics that you might encounter at some point in the course, and so I thought it was important to kind of briefly talk about them. A really common way that we use shell scripts on Linux systems is to process the contents of a set of files that are located in a directory in our Linux server. For example, you might have a case where you have customers who are uploading files and via a web application. Those files are stored in a directory on the server. We might want some sort of script, some sort of automated process which will sort of evaluate and perform some sort of action on all those files in that directory. That's really easy to do with the shell script when we take advantage of what we call the globbing feature in a shell script. The shell script interpreter, when it's evaluating our shell script file, when it sees any commands that contain an asterisk character, it will replace the asterisk character with a list of matching file names. This is a really powerful feature in the interpreter. Here's a simple example where I have a shell script statement. I'm using the echo statement, so I'm going to print out, in this case, a list of JPEG files in my current working directory. When the interpreter encounters the asterisk character, it immediately replaces this value with a set of matching files in my current directory. And then it will run this echo statement for each file that it finds in that directory. So this is kind of like a while loop in the sense that it's like, or a for loop, I guess, in the sense that it's looping over a list of files, and it's going to execute a command using each file name. Here's another example, a short shell script where I got our shebang bin bash statement, which begins our shell script. We're going to do a for loop. We're going to loop over a set of files in our current working directory as referenced by the asterisk.jpg command, a set of JPEG files. And for each JPEG file, it's going to take the name in that file and assign it to the variable X. Then in our loop block, we're going to copy the value that's in the variable X, which is going to be whichever file we're currently iterating over. We're going to copy that to the value of X dot BAK. Essentially what this is going to do is it's going to copy every single JPEG file in our current working directory, and it's going to copy each JPEG file to another file that ends in the .BAK extension, essentially backing up all of our JPEG files. So you have like a 5-line bash script that backs up all the files in our current directory. And it's taking advantage of the globbing action, a feature that's made available by the shell interpreter. Another really powerful feature that you'll find in the shell interpreter is command substitution. What command substitution does is it takes the output of a command and it allows us to use it as part of a statement. And this seems a little weird. This is another area where our shell script really diverges from our typical programming language. There's two different ways we can do shell command substitution in a shell script. We can bracket the command with parentheses, or we can use the backtick character. We can surround the command with a backtick character. So let's look and see what this script is doing. Shebang bin bash, and then we have a variable called files. What we're going to do is we're going to assign the variable files with the value of the output of this command. That's what the $ parentheses means. $ parentheses means that the interpreter should execute everything that any command that is encapsulated by the parentheses. The interpreter is going to run the ls command, which will list the contents of the current working directory. And then it will take that output and store it in a variable called files. The variable files will now contain a list of files. Pretty cool. The second variable is web_files. And this is doing essentially the same exact thing. But instead of using $ parentheses, we're going to use the backtick character. The interpreter will run this command, will list the contents of the directory /var/www/html. And that list of files will be stored in the web files variable. Each one of these variables then is going to be printed out to standard output by the script. Very, very common to see command substitution in scripts. It's extremely powerful. It can also be a bit dangerous, especially if these commands are being dynamically determined. The key here is just to understand that there's two different ways you can do command substitution. And generally I see that, depending on who is creating the shell script, people have their different preferences. I prefer to use the $ parentheses. I think it's a little bit more legible than the backtick character, but you'll see both of them used frequently in different shell scripts. Okay, and so another advanced feature that you'll find in shell scripts is parameter substitution. What parameter substitution allows you to do is to manipulate variable values. Probably the most common way that we use parameter substitution in a shell script is to assign a default value to a variable. Let's look at this first example script. We have shebang bin bash. We have variable 1, and we assign that the value 1. We have variable 2. We assign that the value of 2. Remember, there's no spaces in this syntax. And then we're going to print out, we're going to echo out the variable 2 minus variable 1. This is doing a parameter substitution. It's actually doing an evaluation, and it's going to then substitute out the result of this this variable evaluation. I mentioned earlier that the most common way that we use parameter substitution is to set a default value for a variable in a script. And here's another simple script. We're going to echo, print out the name is, and then you see the $ curly brackets syntax. Remember, this is a way to sort of fence off the value of a variable from surrounding text. In this case, we're also using it for parameter substitution. So you see the name of the variable, which is just name, and then you see the syntax :sam. What the :- syntax means is that the interpreter will print out the value of the name variable if it's already been set. But if there's no value set in the name variable, if that variable has no value, then the interpreter will default to the value sam, and it will display that value. So that's what this : syntax is signifying. It's saying that this value sam is a default value for this variable. Very, very common for us to use this sort of default parameter substitution within our shell scripts.